Hi, this is Jacob Nash with JNGL. Today we are looking at Unit 1, Lesson 2, Standard 2.2, and it is about parallel or angle postulates and also angle relationships. Now, we already knew some of them from a different video, like vertical angles or adjacent angles, but this is even different ones. Okay, so the first term is transversal, and that is, well, the direct definition is a line that intersects two coplanar lines at two distinct points. So those are two distinct points right here. And the blue line, line C, is the transversal because it intersects with lines A and B. And what it means is that it will make the two it will have them parallel. So that's what these things mean. That means that these lines are parallel. And it also will create 8 different angles, all in these places, that have certain relationships that you'll learn about. Okay. So here are the different possible angle relationships. So the first one is corresponding. Magicians. So that's a game. There. This shows how corresponding is. So this is a game that I used to play when I was kind of little, and it's a good example of how things correspond. All happens to the other. So do you see the green and the red magician? They do the same thing as I'm pressing the keys, and they both jump if I push jump, and they both move as I move. So that's what corresponding is. They are just equal at the same parts. So which ones are corresponding? So first of all, let's keep in mind that this means angle. So that's what that symbol means. So the ones that are corresponding are angle. One example is angle 1 and angle 5. They are corresponding because you can think of the 8 angles as 2 separate parts. So the 2 parts that you can think of them as separate is this part right here and this part right here. Now think, if you were to take this part and put it on top of that part, which ones would line up? That's all corresponding means. So the other ones that are corresponding are angles 2 and 6, also 3 and 7, and also 4 and 8. Those are also ones that are corresponding. So that's what that means. Now let me get rid of that. Okay, now alt-int angles, which means alternate interior angles. So if you think about alternate, it just means so there's different areas on angles like this. This is an exterior area. It's not working very good. This is an exterior area, and this is an interior area, and this is another exterior area. So alternate interior. So the interior angles are 2, 5, 4, and 7. Now which ones are alternate? Well, they're not going to be the ones that are next to each other. They're going to be the ones that are across from each other. So 2 and 7, those angles are alternate interior. And same thing with 5 and 4. Those are alternate interior. So we can just use one example, angles 4 and angles 5. Angles 4 and 5. Alternate exterior means the complete opposite. It's just which ones the exterior angles are 1, 3, 6, and 8, and which ones are across from each other just like that. So 3 and 6, and then 1 and 8. So we can just use an example of 1 and 8. Alright, that really got messy, so we can... I'll just see if I can get rid of that. Okay, I cannot get rid of that or it will erase the whole thing, but I'll talk about this one. Consecutive interior. So interior is just the inside, remember? So, but what this means is instead of being alternate, they are just by each other. And you can also call them same side because they're on the same side. Now be careful not to choose the ones that are on a separate side of the line. That's not what it is. It's the ones that are on the same side of the line and are across from each other. So I'll do this in green. 2. Okay, that's bad. That's bad. Let's see if there's any here. Try that's what I'm gonna do. Okay, good. 2 and 5 are ones, and then also 4 and 7. Now that gets really messy, so if you didn't get everything, just reload the video. Rewind. So 2 and 5, that was an example. And this is not very easy to write on, so if you can't understand what it says, sorry. Okay, moving on now. These are the different postulates and theorems of angles. So these are the things that you'll need to know to be able to solve things. So if a transversal intersects two parallel lines, so that's happening with this down here. This one is the transversal, and those are the two parallel lines. And yeah, I should put those symbols on it to show that they are parallel. But these are the 4 things that happen if that transversal does what it's doing down there. So these 4 things. The first thing is corresponding angles are equal. The second thing is alternate interior angles are equal. The third thing is alternate exterior angles are equal. And the last thing is consecutive interior angles or same side angles add up to 180 degrees. So remember, this thing means congruent. I might have been saying equal. They are equal, but they're also congruent. So that's what that means. And basically all the things that you just heard about on this slide, it means that they'll all be equal except for this last one. That means that they add up to 180. And we also know our vertical angles rule, so that will help too, that the ones that are across from each other. So using that, you should be able to know all the measurements of these angles just by knowing this 100. Well, first, we can also use the rules that we know that are with the supplementary angles, but for this case, I'm just going to use the rules that we know up here. So corresponding ones. Which one corresponds with this one right here? I'm going to just name all these. Let's say this one is 1, this one is 2, 3, that's not very good. Up here, this one's 3, this one's 4, and then this one's 5, this one's 6, this one's 7, and this one's 8. So which one corresponds with 1? It is 5, and knowing that rule, we know that that's 100 also. Now, we also know that alternate interior angles are equal. So, which one is the alternate interior angle with 5? 4. So we know 4 is 100 degrees also. And which one corresponds with 4? 8 does. So we know that's also that case. Now, we also know that alternate exterior angles are equal. These two right here, they're equal, 1 and 8. They're already filled in. But then consecutive interior angles add up to 180. So 3 and 5 and 4 and 6 are like that also. So they add up to 180. So we know that it's going to that 100 plus something, let's just say x equals 180. Let's just say that's 180. I don't feel like writing that, but we know that is 80. So we can write 80 because we know that's what that is. And then using our alternate interior, or just knowing this rule for this one, we know this is also 80. And then we also know which one corresponds with 6, angle 2, which is 80 degrees, and which one corresponds with 3, 7, which is 80 degrees. So really, there's only 2 different measurements that each angle has. But using the supplementary rule, we know that 100 plus 80 equals 180. And you might think, well, is there consecutive exterior angles? Well, technically, because you see this 2 and 8, but we just don't really talk about that. But that's technically a thing. Okay, now we have to talk about no fun examples. So you might be asked questions that are no fun, but they will be not no fun after you understand how to answer them. But if you get a question like this, you'll be like, well, there's not really lines. Well, there is, but you just have to make them yourself. So here's how you do it. You will find the 2 lines that form the vertex that the measurement that you know is at. So the vertex of 3x is right there. Which 2 lines form it? This one right here, and then this one right here. So this goes out like this. And which one forms 2x minus 5? Well, we already drew one of them, and then another one like this. So you can pretty much ignore this one that's black still, because it doesn't matter. So now we know this one right there, that's the transversal, and then these other ones are the parallel lines. And then you would solve like that. These ones in here are they are the ones that are consecutive or same side. So we know that 3x plus 2x minus 5 equals 180, and you would solve like that. That's how you would do that. No fun example number 2. Well, you kind of do the same thing. You just draw out the lines that form the vertex that the measurement is at. So the 100 right here, this is the vertex. The lines that form that are this one right here, and then this one right here. And then this question mark that you're trying to find, it is the one I just drew, and then this one also. So now you have it. The other lines that are there, you just can ignore because they do not matter in this question with what you're being asked. How you would solve this is we see that these are alternate interior angles, because this is the interior area, like I already talked about, and this is the exterior. Okay, now practice. These are the practice questions. For this video, for the sake of it, I will post in the description of the video what the answers are, because I don't want to make the video too long explaining, but I will also explain in case there are. Well, I don't really need to explain for any of them. I can just say what rules there are, but for 5 and 6, I might need to explain it. But I can show you that. So you can try to do these and check your answers in the thing below. And then, last slide. Thanks for watching. That's a nice picture. Yeah, I took that picture actually. Okay, well, thank you